Assalamu alaikum. Welcome to the course of Digital Logic Design. In this series of lectures, we have started with the introduction of sequential logic circuits. Here we have given a block diagram of a sequential logic circuit, which combines the combinational logic along with the storage elements. These storage elements defines the internal state of the circuit. The internal state of these elements can be changed with when a central control input is applied, such as a clock signal. This clock signal can be referred as CLK, or it can be also called as CLOK. So let me write it as CLK. This clock waveform has a certain properties, such as it is periodic waveform of pulses and it has different logic levels, such as high level and a low level, a transition from high to low and a transition from low to high. So based on it, different storage devices respond differently. So fundamentally, we are focusing on latches and flip-flops as storage devices. Keep remember that latches only responds to the level of a clock pulse. Whether the clock pulse remains high or low, latches will change the internal state of the circuit, while flip-flops will only respond to the edges of the clock pulse, such as the edge transition from positive to negative or from negative to positive. This is called a negative edge, and this one is called a positive edge. So let's consider a latch is a storage device. For example, if this is a D latch with enable input En, as you know that D latch only responds when there is a high signal on the enable input. So if there is a high signal on the enable input, data D will be processed and there will be output Q and Q dash. So whenever output Q and Q dash appears, it goes back to the combinational logic circuit and it comes again as an input to the latch. Now the signal still remains high and the output changes again. So this process continues until the signal remains high. So we cannot state the internal state of the circuit, because now the internal state of the circuit is unstable. This condition is called the unpredictable condition of the latch, because with this unreliable operation, one cannot state what is the internal state of the sequential circuit. So that is why we cannot use latches as a storage devices. As already discussed, that latches cannot be used as a storage devices, because it responds only to the level of the clock pulse. Similarly, when using latch as a storage device, internal state changes continuously and internal state cannot be determined. This unreliable operation of the latch causes the internal state unpredictable. Now let's consider flip-flop as a storage device. As we know that flip-flop responds only to the signal change of the control input. So for example, in this case where the signal change from positive to negative. Similarly, at this edge we have signal change from positive to negative, and similarly in this case. This flip-flop is called a negative edge triggering flip-flop, because in this case signal is going from positive to negative. We could have also flip-flops where there is triggering on positive edge, which will be called flip-flops with positive edge triggering. So, for example, if a certain data D is applied and we have an output Q or Q dash, so the change will only happen when there is an edge change. So, for example, if this is fed back again to the combinational circuit and now we have new inputs, so the state will only change when there is a change in the control signal. So, we can actually maintain the internal state of the circuit. That is why latches cannot be used as a storage devices, while flip-flops can be actively used as a storage device because they maintain the internal storage of the circuit. Thank you.